You only need to know two things about a normal distribution. It's mean and standard deviation. Once you know the mean, once you know the standard deviation, you know everything you need to know about a normal distribution. One of the reasons people love it is you just need two pieces of information. The mean defines where the highest point on the curve is, and the standard deviation defines how spread away from the data it is. The higher your standard deviation, the more spread out your data is. The lower your standard deviation, the closer the data is to the central tendency. And then finally, we're going to use something called a standardized normal. And a standardized normal has a mean of 0 and a standard deviation of 1 to find the probability, or what we'll consider the area under the curve. Probabilities are areas under curves. So what we're going to do is we're going to draw our probability distribution, find the area under the curve, and then that is our answer. So this is a little bit different than things we've done. And that's what this is. This chart is a standardized normal distribution, and this will help you find any probability that I could ask you to find. Any questions? Everyone feeling okay with this so far? So, what we want to do is we want to actually use the C chart. We're going to try to find probabilities. So what we're going to do is I'm going to start with just doing some simple probabilities using the standardized normal table. Once we've done that, I'm going to move on to slightly more complicated problems where we apply this to a general question. So I'm going to start off with this one. The way this reads is this is So what I'm asking here is I'm asking, what is the probability of being between the mean, where the mean is 0? The mean has a z of 0. So what's the probability of being between the mean of 0 and 1.67 standard deviations above the mean? So what is the probability of being between the mean of 0 and 1.67 standard deviations above the mean? So that's what I'm looking for here. Now, what I'm going to suggest to people, and I noticed one of you actually was already starting to do this, was draw out the normal curve. Okay? with any problem with the normal distribution, it's easiest just to draw out the curve, shade in what you're looking for, and then see how the table would help you fill in what you're looking for. So in this case, the normal curve looks something like this. Don't worry if your normal curve looks a little different, if you have one that's a little flatter or one a little bit steeper. You'll notice as I start drawing these all out, mine look a little bit different each time. That's okay, there's nothing right or wrong about doing this. The key is that you want to have a peak in the center, and that peak is at 0. So I have my normal curve, mean of 0. I'm looking, what's the probability of being between this mean of 0 and 1.67 standard deviations above the mean. Where you put 1.67 doesn't really matter as long as it's above 0. Okay. So I can put it there. And so what I'm looking for is I'm looking for this area here. I'm looking for the area between 0 and 1.67. And if you look at your chart here, so if you're online on Blackboard, you have the C chart, and it has a little picture for you right here. And if you look at that picture right here, and you look at this picture right here, they pretty much look the same. Okay? What the chart gives you is the chart gives you the probability of being between the mean of 0 and so many standard deviations above the mean. So in this case, what you want to do is you want to go down, and it breaks it down into the ones and tenths, and then along the top are the hundredths. So what we want to do is we want to go down to 1.6. Okay? So we're going to break this down to 1.6, and then we're going to break it down into 0.07. So what we're going to do, go down. Here's 1.6 right here. 1.6 is right here. And then from 1.6, we're going to go across to the 0.07 column. And in this case, we find when we do that, yep, 0.4525. So again, if you look at your chart, you go down 1.6, then you go across the 0.07 column, you find 0.4525. And so what this tells us is the probability of being between the mean and 1.67 standard deviations above the mean is, in this case, 45.25%. Any questions here? I was about ready to get to that one. So let's do below the mean. So what about the probability So why don't we do this one? And I'll give you a minute to work on this one. What is the probability that C is greater than negative 0.45 but less than 0? So what's the probability of being between the mean and 45 hundredths of a standard deviation below the mean? Okay. So in this case, a negative number with Z represents standard deviations below the mean.